Hello, good morning. Today I am discussing about the solid state NMR, powerful technique for investigating the sustainable and renewable cellulose-based materials. Uh, in this spectra, the NMR untreated sugarcane bagasse NMR spectrum was extended over chemical shift from 57 57 to 108 ppm. 57 to 108 ppm. C6 carbon 6 is 57 to 67 ppm. C1 100 to 108 ppm. C2, C3, and C5. The cellulose ring 70 to 80 ppm. C4 80 to 90 ppm. The cellulose amorphous 84 and 85 ppm. The crystalline region possessing uh, narrow fitting and sharpness corresponding to alpha 90 ppm, beta 86 ppm, a mixture of alpha and beta 89 ppm crystal structure and 88 paracrystalline cellulose. In this is some explanation of NMR untreated sugar bagasse. The cellulose polymorphism in plant primary cellulose C1 105 ppm, C2, C3, C5 70 to 75 ppm, C4 89 ppm, C6 65 ppm, 1 alpha allomorph C4 chemical shift 90 and 89 ppm, 1 beta C4 89 and 88 ppm. This is the some explanation of cellulose polymorphism in plant primary cell walls. This is the C13, 2D C13 inadequate correlation spectroscopy spectra. The inadequate 2D C13 inadequate correlation spectroscopy is always difficult to detect C13 connectivity by NMR because the low natural abundance of C13, that is 1.1% only, that the finding C13 nuclei adjacent to each other in the same molecule is very low. The inadequate experiment is designed to detect those rare instances where two C13 atoms are adjacent and coupled to each other, and this allows correlation between them. This is some explanation of inadequate C13 correlation. The lignocellulosic biomass structure integration, uh, the polysaccharides, carbons, and lignin methoxyl uh, are examined at 56.5 ppm, and intercellular cross peaks to the aromatic lignin carbons can also be seen 115 to 153 ppm. Explanation of lignocellulosic biomass structure interpretation. Effect of oxidation or pulp in viscose cellulose. The main results include the noticeable resonance between 85 and 93 ppm, mainly correspond to aldehyde hydrate. Formation of hemialdol structure between two newly formed aldehyde groups having a peak around 97 ppm and originated from C6 between 65 and 69 ppm. Effect of oxidation, pulp and viscose cellulose. Explanation. The carboxylic group, the production of crystalline nanocellulose via oxidation of microcrystalline cellulose, carboxylic group interacidic form shows the peak at 171 ppm, in sodium binding form at 174 ppm. Rhodium modified cellulose nanocrystal 188 ppm, which confirms that a chemical interaction occurs between the carboxyl group and the surface of the rhodium base modification. Production of nanocellulose by oxidation, nanomicrocrystalline cellulose. The C13 spectral for the surface modified cellulose nanofibril, including cellulose nanofibers, fluorilated cellulose nanofibrils, melamide modified metronidazole on cellulose nanofibers. In the future, opportunities for the nanocellulose is drug delivery carrier, especially due to the nanocellulose have ability to form different 2D and 3D nanostructures. And its stable behavior after exposure to freeze drying, and rehydration. When drugs are loaded into cellulose-based nanocarriers, so that the future opportunities for nanocellulose is drug delivery carrier. First of all, it has ability to form 2D and 3D nanostructures, and its stable behavior after exposure to drying, and rehydration by drugs are loaded into cellulose-based nano carriers. This is my reference. Thanks for watching.